Assalamu alaikum. Hello everyone. This is Mr. Khan from Pakistan. You know me from RealXenomania. Today's lecture will cover how to create correct pages for any kind of instruction or function inside the ARM32 and the ARM64 instruction set or architecture. Sorry. So let's say we have a library which is 32-bit Lebanogs, and we talked about this function 43206. This we are going to take as example. You see, if you press G and you come here like this, you will see this function. By the way, this layout, you can see my settings here. The 4 is here and these are my settings. You can pause the video and copy them. Okay, these are my settings here. Okay, so using those settings you will see the instructions here. By the way, let me stop close the auto comments here, so this is a bit clear. And let's say we are going to patch this function. By the way, let's see where it is being called from. It is called from this location case 10, and when it is run, it is going to return something here. We want to return a certain value that will stop the detection of emulator in case 10. So what we can do is analyze this function here by double clicking. You see the result which is being returned here. If it is 0, it is an error signal, already we know it. And if here at the start of the function, when these small sub functions are not run, if we return -1, it would mean that there is an error. This function should not have been called. Okay, so this is kind of like an error signal here. So we know about our 43206 that this is going to be an error signal is -1. And if you go forward, there is another return 0 here. If not, v17, and v17 is going to be this. If this function returns 0, it will return 0 from here, and this is going to be a problem. Okay, so it should return a certain result which is 1 here. Okay, this 1 is being returned here, but also it is checking other things also. If we return 1, it is also going to be a problem. So there are 3 error signals here: 0, -1 at the start, which is a severe error, and then here we have 1, it is like less severe error, and then here -1 is severe error. Okay, signaling back. If it is 0, if we go down here and it is returning 0, it is less severe error, and it is weak error signal. Okay, so also let's see if what kind of response when running this function is expected by the caller. So let's also find out who is expecting a return value from that function. Okay, when this function is called, we already know that it is being called from here case 10. but we don't know uh, who is calling it from outside of NOSDK IOCTL. So we have to decompile it from somewhere. We have to find out all callers of NOSDK IOCTL old with the first parameter as 10. Okay, so we can go here and we can jump to our function NOSDK IOCTL old. Okay, and we can find out who is calling by control X here, and we can see all these functions who are calling it. So one by one we can check it. Let's say we are going to check this one, 34254, and see it is being called by case 49 here. Okay, this is case 49, so it is not required. We go to the next function, get report data, and it is calling this function with r0 as the first parameter, is 1. This is case 1 here, so let's also forget about it. What about these are recursive calls. Recursive calls are calls that are done from inside the same function. And let's go to NUSDK IOCTL. This is like an interesting function, and we see here case 10 here. This is 10 passed here, and we can see in decompile mode NUSDK IOCTL old underscore 0 is being called with case 10. The result is going to be saved here, and if the result is 1, then there is going to be a problem. The emulator is detected already. The emulator detection is done with 263574. This we already covered in we already covered this, you already know. We covered this in the previous lecture. So the first thing that we see here is, if we are going to patch 43206, we are also going to patch this sub 263574 also, so that it cannot run and save the result, process the value here. We have to find some smart patch for it later on. Okay, we can also destroy this function completely, 263574. Alright, we can see who is calling it. A lot of functions, 374 functions are calling it, so it could be something that is repeatedly done, like reporting or logging or something else. A copy, so this we see an interesting function here, so we can search internet about this function. What is this? This function is in native C. This function is copies macro from source to destination. Okay, this is the function. This is a void type, this virtual array list or something like that, VA list, I don't know what it is, but this is a VA list. Let's see what is it. VA list is a complete object type suitable for holding the information needed by the macros via start via copy. Okay, this is a customized array type of thing or information, or this is an object basically. And so this is VA copy. It copies one argument to the other, so the source is on the right side and the destination is on the left side. So in here in our library we can see that it is copying VA to V10. Okay, and VA here is VA list, and I don't know what VA list is here. It is coming from the stake value of this function. It is from stake pointer plus 2ch. So we can see that this function The default return type is integer, and the result is equal to 0 if a2, which is the second parameter passed to this function, is greater or equal to 1. Then some calculations are being done here. After that the result changes, and then that result is returned. But if these calculations are not done, we can simply return 0 from here, and this function will be disabled. So we already know that this function we can return 0 for it. Okay, so we are talking about how to create this page. We want to return 0, so this thing will run, this body will not run. Okay, how can we do that without starting or whatever there is? So let's see, going back to our functions here which we were studying. Returning 0 will disable this function. But what about this caller? This caller is expecting from this nostcalctl old a certain value that is going to be returned from here. If that value, which is result no, equal to 1, then something will happen. Emulator name will be logged, or some other thing will happen. We don't know, but we see the emulator name string, and we know that this is not a good thing. And otherwise, when we write programming, we already know that there is an if body, if condition. Okay, and if we don't write else here, it will automatically be considered as else. Okay, automatically considered as else. So if the result from this function is 1, this two functions will run, otherwise these things will run. Okay, so we want to avoid returning 1 here. The only thing that we are going to avoid is returning 1 here. Okay, so also you have to know that in this nostk another variable v19 is passed as reference. v19 is a local variable here. It is declared here inside case 10, and then it is also it is modified inside this nostcalctl old underscore 0. So let's see, it is the third parameter, and the third parameter is modified by this function. Let's double click and see it. The third parameter is going to be this function. So the third parameter that is passed here, a3, this was previously the v19, which is passed by reference here, by address here. So this function can modify it simply by dereferencing it, like star v19 equals something, and it will change this value here. And then based on this value, when it is changed by this nostk it is used further down in this function. So you see already that if whatever is happening to this value, it can affect a lot of things inside memory of the game, because this is a large function, and when it is called, this value can change. This is a local variable in case 10. When it is changed, and it can affect a lot of things inside also based on certain calculations. But whatever is returned here, this function can also modify v19. So we have to first verify we can disable this function by any other thing other than 1. Like we can return 0, we can return -1, we can return whatever number you want. And if it is not equal to 1, then these two functions will not run. But we see that there is a value passed as address, and this can affect certain calculations inside this function, and if it is equal to 1, then it was supposed to be used inside this function too. Let's hope that this function is called only once here. So we can go to this function here, and we can find its xrefs. We already see that a lot of other functions are also calling it. Okay, so it is called from any NOSDKCTL all plus 8a, which is this location here, which is this location, and it is also called by the same one at 94 location, which is also this one. Anyways, and there are other functions also which is calling it 262 DCA and using it for some calculations. But whatever this function is doing, we don't know about it. We should not be too concerned about it. But the main thing is this, that if we disable this function, even if this value is passed as a calculatable quantity, this call basically defines, it is telling this function to calculate something, return back to this value here, so that it can use it again in this function. So if we are disabling this and we are returning some value from here, then that value, whatever is it except 1, it will not enable this call, which is using this variable calculated by this NOSDKCTL old underscore 0. Okay, so it means we can return anything from here except 1, and it will still bypass the emulator. So we now know, we have reached a conclusion that when we were talking about these error signals, the returning 1 is a weak error signal, but it is also a signal for emulator. Okay, and this is an error signal, and this is a less severe error signal, but it is still an error signal, and we can return any other value. Okay, return any other value other than 1, because the result is only checked here once, nowhere else it is being checked here, case 10 here. But we have also got to see if this NOSDKCTL old when it is running case 10, if we want to return a certain value, we want it to be consistent throughout library. Obviously, you would think that this call of case 10 is being done only one time here, but we have to be sure about it. We have to check this library. So the best thing for you is to produce a file, create a C file like this, save it somewhere, like I have saved it here in this location, lebanox.c. You can save it in any other location you like, and then save it. When you click save, it will take some times, like 1 minute or 30 seconds, depending on your hard drive and processor speed. It will generate a function that you can it will create a library of all the functions in C language. You can analyze it better. Okay, let's find at lebanox.c. We have it here. We can open it with notepad here, and then we can find this thing, NOSDKCTL old underscore 0. Make sure your case is off, and we are finding case 10 here, so we will write it like this, and we will click that button. So you see that not only is it being called here, but it has actually two places where it is being called. The first one we already saw. Okay, this is the same location that we were studying. This is the NOSDKCTL underscore 0, and then there is another location also which is calling case 10. We have to analyze it also in our library. We scroll up here, and then we find this secret location here we have just discovered, and let's add it to our pages. This could be a good thing. And we have some other thing. We don't want to mess with this function. and we want to verify this now. So these 0 1 -1, these are not good pages. Okay, and this is 271E0. Let's go there. Insert a call also, or you want to jump to here also, and then we can decompile this function. This function is, let's see who is calling this function first. So it has only one caller. Okay, it could be from outside of the library, or we don't know. And let's also see how many functions it is calling, and we can see a lot of functions here. It is calling no IOCTL with case 10, get report data, delete report data, things like these. Okay, so we are interested in this call case 10 when it is calling case 10. So unlike the other function call, it is not returning something and then checking it. It is simply calling case 10, and it is changing v8 here. We are interested in this address which is being passed. This variable which is being passed here is an address, and it will be returned after some calculation here, this v8. Let's see if in this same function v8 is being used somewhere. No, it is not being used, but still this is from the stake pointer. So obviously when it is calling it, it can be used from the stake to another function. So not all functions communicate with each other using return values. Some special function use stake pointer or stake variables like these, and then they communicate to other functions using the stake values. Okay, so we are going to check what results are being returned from this case, and how is this parameter, which is the third parameter, being affected. Also there is another parameter here, v10, and we see that by default it is given the value 0, and then it is being used down in 267 bb2. It is also used as an address, so it will also calculate something and return back to it. But obviously this is not being used here right now, and this address, this variable is also from the stake. So the address v10 means that this function is going to effectively affect this stake value. Okay, so sorry for the background noise, we all are family people. I'm trying to pause the video again and again to avoid any kind of noise and annoyance for you. But see, this v8 we have to take care about, and the v10 here we have to take care about these two things, because these are being modified from within the no function, and also these are modified in 267 bb2. So just by a detailed study of the emulator bypass inside NOGs, we see there are some functions which are involved in finding one way or another way whether we are doing something illegal according to the game or not. So this function, we are here now, and we see that there is no return here. This is a continuous function. This sleeps for 2 seconds here, and this is running non-stop. Each time it is running for 1 second, then it is checking get report data, delete report data, SDK on receive data at some of these functions. Okay, these are some functions that are being checked, and some like these functions, when these are run, they are communicating in a hidden way using variables. So obviously, like you see, dereferencing the value of this v5, which could be an address, coming from v4, which is run and found from this function, by passing v3, which is passed from this function by calculating through 1, by dereferencing the address which is contained in v1 plus 120, like this is a relative pointer. This is a pointer v1 address. It points to something, but that thing plus 120 is going to be our target here, which is v3, and v1 is passed from a1, which is this thing. So all of these functions depend on v1, which is passed from 271 edc, and we can also check the value of the stack pointers before and after the instructions are run. We can enable those from here. We can see these are the stack pointers before calling certain functions, and we can check according to our needs. Okay, so here when the NOSTK IOCTL is called and v8 is passed, which is on stack pointer plus 8 hex. Okay, so this is the call is here, and this is the value of the stack pointer 148 plus 8 will become like 150. Yeah, and 150 is going to be the value of v8 here. That value, whatever that value is holding, it is being passed to this function along with case 10, and that value some calculations are being done inside this function. The value is going to return back here. Okay, and after also this v10, which is a local variable here, is passed to this function, and then returned some calculations are returned back to this v10. 2 seconds later, when the library is loaded, an infinite loop, a thread is started. And this is a thread. Okay, so this has no return. This will continuously run and call these functions again and again and again. Every second, one time in every second, these functions are called. And obviously we have v1 as the first parameter here, and we don't know what the first parameter passed here is, so let's verify it. It is being called from this location, and the first parameter it could be anything. It could be passed from an external library. We don't know, whatever that, because we are analyzing statically. That is why sometimes we don't know things, but we guess and we move on. So whatever that thing is, it is passed to v1, and on that v1 some calculations are done here, and then all of these things are running continuously. So we can like disable this function totally. But what will be the effect of disabling this? This thread will obviously not run. In case 10 will also not run. But we can also do some other thing here. Let's see, the v8, it should be modified by the call on this NOSTK old. So we can like disable this call completely, and this call is here at this location 271 f22, and we want to disable that call completely. And in this function we are going to use our call disabling method. This is the call to IOCTL, and we want to disable it. Okay, we want to disable the call. For disabling, the first thing you have to know is the NOP. NOP stands for no operation, and no operation will tell the processor to simply do nothing when it reaches here. Okay, when it reaches here, we want to tell the processor to do nothing. Okay, so the first thing that you have to know about the NOP, you can browse this site armconverter.com, and you can reach at first, and this is the second website, disassembly mode. Okay, these two websites we are going to use. The first website, the code website, we will use to write code so that we can convert it. So we write NOP here, and in ARM64 it will be like this. So we are not working in ARM64, but in ARM32 it will be like this, but also in thumb mode it will be this. So how can we choose which function is going to be the correct one? The best identification will be the size of the instruction itself. This is a 4-byte instruction, 4 bytes here. So we will choose something that will not change these bytes. Like if we have something of 2 bytes, we cannot write it here in 4 bytes. We have to choose an instruction that is 4 bytes long here. Okay, so here we see the ARM version of the NOP is 00F020E3. We can copy that and we can put it here in our patches. The first patch is this one, so we can create 27 1F22. okay, this is going to be our patch. You already know that the Game Guardian users can use this thing, you know, this thing, and cheat engine and other CPP users can use like this. Okay, you already know these things, I don't have to repeat it. Okay, so this is our first patch that we have made about emulator detection about case 10. okay, this is case 10. The next thing that we were trying to do is how to patch 43206 correctly. So we were studying these and we found out that we can come here, and there was another function that was related to the call, which is the 267 BB2. 267 BB2 is here, which was using the V10 calculated here. So if we disable this call here, the V10 will remain 0. okay, the 0 will pass to this function here, address of V10, so it is automatically 0. 0 will pass here, and if the first parameter is 0, A1 is 0, then it will return minus 19. Interesting. But if the first parameter is a non-zero thing, then it is going to calculate some things here from stake pointer, and then it will come here, pass A1 here, and it will create a result. Let's say that A1 is not 0. Let's imagine we will come here. Now this is a non-zero thing, and we already know that it is a non-zero. It will be passed to V2, and also it is in A1. okay, A1. So A1 is used here, and a result is calculated, and we already know that this is a non-zero thing. Non-zero thing here, non-zero thing, second parameter here, non-zero thing calculated something. After every calculation is done, the value 0 is returned here. So this thing will bring result 0. When result 0 is returned, it means that this function has run, and after this all of these things will run. Result will become -2. -2 will return here. We are assuming that this is a non-zero. When -2 is returned back here, -2 will return from this 267 BB2, and this was our target. -2, return -2 from here. Alright, and we can avoid all these things, and return -2 from here, so that what we were doing in the previous step cannot become suspicious. 267 BB2, let's see if it has multiple callers. Yes, it has multiple callers. Let's see the first one. The first one is also calculating something. If not results, then do something. -1 result -1. Yes, okay, no problem. We can return -1 here, okay, and this thing will not run. -1 will return. This is -1, so we are on the correct path. Let's see again another one. -1 is returned here. This will not run. -1 will return. Okay, so it's easy. Let's go again to the other caller for 1C. Decompile it. -1 return here. If -1 or something greater than or equal to 5, true or false. If true, if false, both are false, some one of them is true, return result which is -1. If these one of them is result is -1, so it is not 0, so it was already, it will also disable this for 1C4C. Okay, it will automatically disable this function by returning -1 here. Okay, -1 is here, it will return -1. That's it. Everything is going to be disabled here also. And another thing, let's go down a little bit and verify more whether we are creating problems or actually solving it. If something, yes, something is here, null sub this, whatever is this, v22, v23, no, null sub for something will run, return -1. So -1 is already returning from here, return -1. That's it. It will disable this function for 91FC. Okay, go back, come here, let's say go to this function. Whatever is happening, returning -1, so it is not doing any effect here, and we already studied this function automatically. Not automatically, previously. Let's see this one. This function, if something, yes, everything, something, it will return -1. It will not do calculations of any of these things. It will return -1. 8056E is also disabled here. Okay, and then again go down to this function. Let's see, disassemble. Result is -1. Is the result 0? No, it is not 0. Run all these calculations and return whatever is calculated here. So only this function 2722A6 is going to be problematic, because no, it is not going to be problematic. It is also disabled. The result is -1, so it is non-zero. Then it is going to be returning result -1. Result is -1. Is -1 equal to something? If not, something is for, oh no, this will run. So it is going to be a problem here for this function 267 BB2. This is going to be a problem. Okay, we will study it later on. Okay, going back, this function here, automatically it is already -1, not calculating anything, returning -1. That's it. Okay, it is also disabling 27316C, which is CTRE. Okay, so all of those functions that you saw, by just making a single calculation, a single investment of 5 to 10 minutes, and by designing a proper patch, we are disabling all things related to emulator. Okay, it could possibly crash our game. We have not tested that yet, but it should work because we are not changing big things. Only this function is going to be a problem for us, so let us analyze it now. This is going to be the fourth function here. when this function is run, this calculates this thing, it returns -1, okay, and then based on this it will calculate everything, and if the result is 0, it is calculating it, otherwise it is returning the result. So we want here from this function to return -1 without calculating all these things. So this function we have to tell it to return -1 here, and this function, let's see it again, whether we were correct or not. When this function is run, it is calling this function. This function is run, it is calling this function, otherwise it is returning -2 if the result is non-zero, otherwise returning the result which is calculated here, which is 0. The result is 0. All of this will run, it will return -2, so we will return -2 from here. Okay, when -2 is returned from here, it will come to result -2 will return. So all of those functions we have to return -2, and from this also we have to return -2, not -1, all of those functions. So now we know which functions we have to patch. We know about the logic behind the patching. Now how to design these patches? The first thing that we have to do is return anything for good patch. We can return anything like it. So some people I see, they are returning -1. Okay, from 43206 they are returning -1. It doesn't matter, whatever you return. I will return the first letter of my name, N. Okay, let's see. ASCII converter. This is just for the sake of understanding, don't take it too seriously. You can return anything from there. Okay, okay, so N, this is 78. I will return 78 from here. Okay, so we already know all of this, so we will return 78. Now what is 78? Is this in hexadecimal? Was it 078? So it is like if I press P, let's see, P 112 P 080 79, then 80. It should have been 8A, so it means these number are in decimal. We can convert it to hexadecimal. It will become 4E. I will return 4E from here. Okay, to bypass 43206. How will I return 4E now? This is the question. I want to return 4E. How can I do it? Return hash 4E. So there is nothing I can do. How can I return R0 hash 4E, then BXLR? And here is how you need to understand a little bit of assembly. So it is saying to me that I have put a certain wrong instruction here. I can return 0. I cannot return 4E because this is not 4-bit align. I can return 4F. Oh, maybe no. I can return any value which is 4-bit aligned, but not which is not 4-bit aligned. So 50 is 4-bit aligned, but if you go to 4F, it is not. 4E, it is not. 4D, so it is 4-bit aligned. Okay, but not the 4F. So 4C and 4B, for A, for 9. Okay, so it is returning for 9 but not for A. Okay, maybe we can write 78 here. Yeah, so it is automatically converting it here. So my mistake, it is automatically converting it to 4E. So we can write a code here, but there is another thing also. The instruction 43206, sorry, come back to 43206. This is a 2-byte instruction here. We can return from here. This is also 2-byte instruction. This is a 4-byte, this is a 4-byte. So we can return from here by observing these instructions. Most of these instructions are in the ARM language. These are in ARM, BNE, move, add, but some of these are in the thumb mode. Okay, so we have to know that the interchanging between the thumb and the ARM mode depends on a certain flag inside the processor. When that flag is 1, the next instruction that is going to be run from the program counter will be a thumb instruction, and the current instruction will be read based on that flag. If the flag is 0, it is going to be the ARM instruction. So in here in this start, we see this is a 2-byte instruction. We want to return from here, so these 2 instructions are in the thumb mode, and we have a 4-byte space which we can use to our advantage and return from here. But we also want to return with a certain value. So you already know that there is an instruction here. We have studied it, 00207047, and this is basically a thumb mode instruction which moves #0 to R0. So all we need to know is that the S has to be added to the move instruction to make it a thumb mode. Okay, this is an ARM mode instruction, and if you want to make it a thumb mode instruction, we have to add it S. So when we add S, the instructions are automatically 4 bytes aligned. Okay, 2 bytes, 2 bytes, both for the thumb. So we can now copy these two things, and we can come to our patches here for preparing it finally. So the 43206, I'm going to patch it with this thing, 4E207047. Okay, now the next thing that this is done, this is complete. Okay, so the next thing that I'm going to disable the call here, which is going to call IOCTL. We already know how to disable, so let's go to by that I mean we know how to disable because we can NOP that instruction. And NOP here we see that the call is going to be a 4-byte. Sorry, this is the function is 271 EDC. Okay, and we have to disable this 271 F22. We have to disable this call BL, and it is a 4-byte instruction. So for 4-byte we have to design an NOP which we can do here by just writing NOP. In the ARM mode it is 00F020E3. We can copy it here, 271F22. So this is going to be the patch here. The next thing is return -2 and return -2 in both these functions. So we have to quickly go to these functions. We are going to return from here, and we see that it is a thumb mode instruction, and we already saw how I designed when I was returning 4E, and this is also a thumb mode instruction. So I can copy it from here and I can write it here 267 bb2, and but I am returning -2. So what is going to be -2 in assembly, in hexadecimal? So you have to understand a certain thing. Let's see, 0 -2, this is -2, but in hexadecimal, in single byte, it is FE. Okay, so I will write here FE 207047, and a similar case I can do for this function. So this is the correct way for patching emulator with as less offsets possible, as less offsets as possible. So this is going to be a patch for emulator detection. Okay, it will not give you termination or 10-minute bans. This was about the no operation and how we were going to return something. The next part of the lecture will be recorded separately. It will cover instruction modifications and function modifications.